Anthony Nathaniel, and today I'm going to talk to you about a foundational topic in chemistry known as atoms, moles, molecules, and formulas of chemical compounds. So let's move on. Now, basically, we have atoms, and atoms are the foundational units of chemistry. Now, atoms were first noticed by early scientists like Calvin, Lane, and even Leeuwenhoek, and many other early scientists, and even scientists that studied biology or biological scientists like Robert Hooke. They discovered cells and they set up cell theory. And a cell in biology is also similar to an atom in chemistry, in that they both form the basic fundamental unit of matter. And both cells and atoms have nucleuses, they have nuclei. So now, but today we are dealing with atoms, not cells. So, and basically, what is an atom? An atom is basically the smallest part of the substance. The smallest part of the substance. Don't say indivisible, just say the smallest part of the substance that can take part in a chemical reaction. So it's the smallest unit of the substance that can take part in a chemical reaction. So it's basically that part of the substance that is the littlest, the smallest that can take part in any reaction that substance is taking part in. And that substance could be a large group of atoms, and that substance could also be a combination of different atoms. So now, if we have two atoms of oxygen, this is oxygen. Oxygen is on the 8th element on the periodic table. Then if we have oxygen like this, oxygen has an atomic number of 8 and a mass number of 16. Now, for an atom like oxygen, if this oxygen alone is called an atom because it consists of just one indivisible particle. But some early scientists believed that atoms were indivisible, whereas today we know that that's not the case. Atoms are actually divisible. So one of those early scientists was John Dalton, and John Dalton in the early days, in the early centuries, he postulated 5 theories. He postulated 1 theory and 5 sub-statements about that theory. So, Dalton's atomic theory, the first thing he stated was that all matter is made up of atoms. That's the first thing, and he says that those atoms are indivisible. So now that first theory has been proved partially wrong, because even though atoms are the fundamental part of all matter, but they are not indivisible, because from many of our reactions, like the fission of nuclear fission of radioactive elements like uranium and so on and so forth, scientists have discovered that most of these atoms can be broken down into simpler atoms by the process of radioactivity. So that they've proved John Dalton's theory wrong. That's first one. Then he said all atoms. He said all matter are made up of small indivisible particles called atoms, which has been proved wrong. Then again he said atoms can never be created or destroyed, and that has also been proved by nuclear fission and disintegration. And even the fact that the postulates that atoms are indivisible has been proved wrong by the discovery of the subatomic particles by Rutherford in the early centuries. And those subatomic particles are called nucleus, protons, and electrons. And an atom consists of nucleus, protons, and electrons. In an atom is something like this. This could be an atom. In an atom, there's a central part known as the nucleus, as we know it today, and that nucleus consists of what is called the neutron, and then it consists of the protons. Neutrons are neutral particles. Protons are positively charged particles. Neutrons have a charge of 0. Protons have a charge of 1. Then outside the nucleus of the atom, we have what is called the electron shells. And those electron shells consist of electrons that are orbiting the nucleus constantly. So that is the basic model of an atom. That is the basic nuclear physics and nuclear chemistry that you should know. Now, moving on, we've proved 2 of John Dalton's theories wrong, right? So next move to the third one, which says that that all atoms of an element are alike in every aspect and differ from atoms of all other elements. And these have been proved wrong by the discovery of isotopes. And basically, what's an isotope? An isotope is basically two or more samples of a particular element that have different neutron content. That means the neutron numbers are different. Now basically an atom of oxygen, there could be isotope of oxygen having different neutron content. So if one isotope has 8 neutrons, another isotope might be having 9 neutrons. For example, let me give an example like hydrogen. Hydrogen is the first element on the periodic table, and it has its number H. It has one proton and it has no neutron. So the atomic number is 1 and the mass number is 1. H11. Now if we have another isotope of hydrogen, it's called deuterium, and that deuterium, it's another isotope of hydrogen H. We have two particles in the nucleus, and those particles, it has 1 proton and one neutron. That's 1 proton, which is the atomic number. So basically the atomic number is the number that denotes the amount of protons in the nucleus of an atom, while the mass number, the bigger number, is often bigger, and it is always denoting the sum of the number of protons and the number of neutrons in an atom. So what I'm trying to say is that in one atom can have different forms, and those different forms will be called isotopes. So that has proved John Dalton's theory that all atoms of an element are alike in every aspect. Then let's move to the fourth one, which was also proved wrong, which says that when atoms of different elements combine together, they do so in simple multiple ratios. And this has been proved wrong by the discovery of organic compounds. And for example, carbon forms very large organic compounds. You can see carbon compounds. Carbon has a special ability in chemistry which we call catenation, and that denotes the fact that carbon can form chains and chains and chains and chains of atoms. So those atoms will be connected in chain from one to another. Like for example, we can say one connected to each other, C. Then we can have different substituents. So I'm actually delving into organic chemistry right now. I don't intend to, but in another video we'll talk about specifically about organic chemistry. But today we are just talking about the fundamentals of chemistry. So moving on, that is all about atoms. Then the last theory of John Dalton was that all chemical combinations and divisions of atoms all chemical combinations and divisions involve atoms. So and that is fundamentally true, because chemical combinations and divisions of atoms, they always involve atoms. So next we'll talk about molecules. What's a molecule? Now these atoms, some of them, they have incomplete exterior valence shells, and basically these electrons that orbit around the atom, if this is an atom, this middle part, this like the core. An atom is just like an egg. An egg has a yolk. So the yolk of the atom is the nucleus, and that nucleus is surrounded by the albumen, and that albumen here is just like the electron shell. Now they have different electron shells. We have K shell, we have L shell, we have M shell, we have N shell, we have O, we have P, and so on and so forth. So depends on how big the atomic number of the element is. That is the amount of shells it occupies, and also depends on the period which it belongs. So moving on, now those shells, if the outermost shell is incomplete, just like the atom needs a specific amount of electrons in order to be balanced, in order to be satisfied. So if it is not satisfied, to keep looking for atoms to balance until it gets satisfied. So if those atoms to balances are available, it will combine with them by forming chemical bonds. And in another video we'll talk specifically about chemical bonds, but today we are just taking the fundamentals of chemistry. And those chemical bonds will involve the coming together of 2 or more atoms. For example, if this oxygen has 8 electrons. Now I've not told you this, but in K shell, which is the first shell, I told you that there are different shells. There's K shell, there's L shell, there's M shell, there's N shell, and so forth, on and so forth. Now the first shell, this shell that is closest to the nucleus, is called the K shell, and K shell has a maximum of 2 electrons. So we put 2 electrons here. Next we have the L shell. L shell we have a maximum of 8 electrons. 1, 2, 3, 4. So and those electrons, they are always in pairs. But before we start counting this, let's look for what is the total amount of electrons oxygen has. Oxygen has 8 electrons. So let's count. We have 2 in this case. 1, 2. Then remaining when you remove 2 from 8, you have 6. So we have L shell we have 6, and that L shell, when L takes 6, L is incomplete simply because L is supposed to take 8, but L takes 6. So we have 2 left. 2, 4, 6. So let's put it first. So electrons, they often occur in pair. So just notice that electrons often occur in pair. Now looking at this now, we need to understand that this electron, this 8 atom has 2 deficit electrons here. So it needs 8, but it has 6. So what it will do is to be combined with another atom, and that atom could be, for example, oxygen. So when it combines with another oxygen here, it will form what is called a double bond. So this oxygen, this second oxygen will come around. Sorry about the disproportion. They are supposed to be the same sizes. Let me clean this one up. So that's the nucleus. This is K shell, and then this is the L shell. So the K shell takes 2 electrons. The L shell takes 2, 4. Now, before we draw the L shell, when we combine these atoms, so they will kind of mix together, bond together, just like families. Then this one will bring one. This one will bring another one. This one will bring one. This one will bring another one. So in that case, in that form, we still have is 2, but it has brought 2 electrons to share, and then the other one has brought 2 electrons to share. So specifically, this is called a covalent bond. But in another video, for those of you who are in SS2, SS3, you will understand what I'm saying. But those of you who are in SS1, you will still follow. You still get to understand in later this. But just follow the part of this video you can understand. So basically, this is called a chemical bond. When you have 2 atoms coming together, and it forms what is called a molecule. So the essence, what I'm trying to say is that whenever you have 2 or more atoms combined together with a chemical bond, you form a molecule, and that molecule could be formed of 2 alike atoms or 2 different atoms. Now, what's a molecule? A molecule is simply the simplest part of an element that can exist independent on its own. So a molecule, now this molecule can exist independent on its own, and we can consider it oxygen. So this molecule, when we in the air now, you probably heard that from your biology class or from your research, you probably heard that we breathe in oxygen and breathe out carbon dioxide, right? So that oxygen, its occurs in O2. You cannot see oxygen as O1. So they always come together to form a chemical bond, and that is called a molecule. So that is what molecules are. So it's the simplest that you can see alone, existing alone. That is called a molecule. Now let's move on to basically, in summary, let me give a summary of what I've been doing so far. In summary, I've talked about the atoms and all the atoms consist of. Now let me move on to the symbol of elements. Now, symbol of element. This element we call oxygen. We represent it by O, right? So there are different ways of representing elements. For example, in 1814, the year 1814, a man named Berzelius invented a method of naming elements. So you can name it from the first letter, like oxygen. Now we have oxygen. We name it O. You can name it from the Latin name. For example, there's an element called sodium, which is the 11th element of the periodic table. If you have a chemistry textbook, you can check your periodic table, and the 11th element will be sodium. Now that sodium, the Latin name of sodium is called natrium. Now you take the first 2 letters of the Latin name, Na. So this is the symbol for sodium. So and so on and so forth. We have different ways of naming elements, but we don't just write the full name in chemistry. When you want to form chemical equations, you have to have shortened versions. So that is why we have chemical symbols. So that is how this came about, and we still use them today. And still, even though more and more elements are being discovered, we are still forming new new symbols by still using these existing principles. So there are principles like you can form from the first letter of the name, you can form from the first 2 letters of the name, you can form from the first letter and any other letter of the name, you can form from the Latin name, and so on and so forth. So those are the 4 basic principles for naming of elements. Now let's move on to after naming of elements, we have what is called let's talk about chemistry of compounds. Now, after molecules are also known as compounds, because compounds consist of 2 or more elements. So a molecule is basically fundamentally a compound. A compound consists of 2 or more elements. So if you have a heterogeneous molecule, and when I say heterogeneous, I mean a molecule that contains 2 or more different atoms, that forms a compound, and that compound will always have a molecular formula, and that molecular formula is the sum of the atomic formula of its different components. Now, if we sum the atomic number of this oxygen, if oxygen combines with sodium, imagine we have a compound known as NaCl. Now, NaCl is also known as salt. It's called sodium chloride, and it's a salt. It's an ionic compound. If you don't understand ionic, I will talk about that in another video. And this compound, when you want to talk about the mass of a molecule, now I said this is a molecule because it consists of 2 different atoms combined together, right? And this could be any bond, but this specifically, this is called an electrovalent bond because it contains a positive. Sodium is a positive ion, and chlorine is a negative ion, so that forms an electrovalent bond. Now in these two, when they come together, they have what is called a molecular formula, and they have their molecular mass. So and this now let me quickly define two terms. We have what is called relative atomic mass, and we have what is called relative molecular mass. Now over the time, scientists have discovered that we have to calculate the masses of atoms relative to each other, because these atoms, they are very tiny that we cannot be calculating the real masses, so we have to take the masses relative to one another. So they now arbitrarily say that the mass of hydrogen, even if the mass of hydrogen is, no matter what it is, they arbitrarily give it as 1, and they say the mass of some other atoms will be in respect to hydrogen, and sometimes they express it in terms of carbon. So the last thing I'll do in this video is I will define two terms, and then I'll use it to look for the relative molecular mass and the relative molecular mass of this one, and the relative molecular mass of our compound of our molecule O2. We'll look for the relative molecular mass of our compound sodium chloride. Now we have what is called a relative atomic mass. Relative atomic mass is the amount of times that when you compare the mass of an atom to 1/12 the mass of carbon 12. So how much bigger it is than the 1/12 the mass of carbon 12. And carbon 12 is basically carbon on the periodic table, and carbon 12 has 12 electrons. Carbon 12, that's C. Carbon 12 basically has 6 protons and 12 protons and neutrons. So basically carbon 12 has a mass of 12 grams. According to scientists, that is the relative mass of carbon 12. So when you divide the mass of carbon 12 by 12, you get 1 gram. So basically, that is the relative atomic mass is the amount of times that the mass of a substance is greater than when you divide this mass of carbon 12 by 12. So when you divide it by 12, you get 1 gram. So that's 1 gram. The amount of times that the mass of an atom is greater than it is the relative atomic mass. That is called relative atomic mass of that specific atom. So basically, for example, the relative atomic mass of oxygen. Oxygen has 8 electrons. It has 8 protons, and then its mass number is 16. So the mass of oxygen is basically the mass number, but the relative atomic mass is often a whole number. But the mass itself might not be a complete whole number. So, but the relative atomic mass of oxygen is 16, for example. So basically, and then the relative molecular mass of a substance, you still use the same method to look for it. In that, in the relative molecular mass of a compound, I said earlier that the compound is a combination of 2 or more atoms, right? So you add the masses of the atoms that make up the compound. For example, this is sodium chloride. Now, the mass of sodium is sodium is the 11th element of the periodic table. If you check your periodic table, if you have one, you will see that the mass of sodium is 23. Then you now add to the mass of chlorine. The mass of chlorine is 35.5. Now these values are the masses of the elements. These are the relative atomic masses. And then in a later video, I'll tell you why this chlorine is 35.5. Why it's not a whole number. You'd have expected that the mass number, which is the number of protons and neutrons, or we cannot have half a neutron. We only have them in whole numbers, right? Except we're talking about quantum physics, and then we talk about all those subatomic particles and all the rest, quarks and all the rest. But we're not dealing with elements. We're not dealing with Einstein's theories. But we could deal with them, but no, we won't. So now basically, I'll explain why this is a fraction. I'll explain why this is as a decimal number. But then you add them together, which will give you 35.5 plus 23. That's 58.5. So you put gram. That's the relative atomic mass. 58.5 gram that's the relative atomic mass of and this is called a mole. When you have one of these, it's called a mole. So I hope this video is sufficient enough to give you the basics of chemistry.